number 5, and it says f of x is equal to 5x to the 4th minus 3x squared plus 6. So what's it ask you to do? It says for a, it asks you to find f of what? -1. And for b, it asks you to find f of 2. What does that mean? What are you doing with -1? You're putting it in for x, right? And if you wanted to use your calculator to do this, what's the most effective way to do that on your calculator?
I don't know how to say it.
Yeah, you enter. Well, I'll just say it. You enter it in as the function into your calculator. So you enter in 5x to the 4th. So I'm entering the function minus 3x squared. This way you only have to type the function once, plus 6. And then when you go back to here, if you're on the main screen, let me clear this here. If you hit vars, you can go to yvars and hit function and y1. And then what do I put in parentheses right here? -1. And what do I get? 8. And then you can do the same thing, vars, yvars, y1. And then instead of, you can just evaluate it again, but we're evaluating it at 2. Look, that is, why is that super helpful?
Because you're gonna have a really long, complicated equation.
Yeah.
And it's gonna be like, why does this my calculator?
Exactly. It's really easy to type it wrong, especially if you miss the parentheses. So this you now know is -8, and this is 74. Let's say I asked you for like 10 other ones. Let's say there was part C and part D and part E. Would you want to have to type the function every time you wanted to evaluate it? This is a much more stable way to go about doing it, because in y1, what did we write in y1? We actually wrote the function in y1, and you can store that and use it. Let me show you one more thing that's really important. When you're working in your calculator, let's say you've typed something out that is really long, and you don't want to have to type it out again, or you want to type out something really similar. Let me show you something here. Let's just say, if I do, does everybody see above the see in the bottom right, you see the little tiny cursor, I'm circling it right there?
Yeah.
This key right here, let me show you, this key right here. You see ANS right there? That means answer right there.
Yes.
ANS. That brings up, if you use it, watch this. If I go second minus and press enter, it does the exact same thing again. It does the exact same thing again.
That's
So
what happens when you you have something and then you have a number and you just want to subtract something. Or
correct.
divide.
So then the other thing that's even more helpful to me is right next to it. Do you see, where is it? Let me find it here. It is, yeah, I did clip the right place. Do you see entry right there? Above the enter key. Do you see entry? That's one of the biggest things that can help you here. So if I go back to the calculator and I go second entry, look what it cycles, second entry. What's it doing? Second entry. It cycles through all of the entries. So let's say I type something really long out. Ready? I'm just making something up here. This is total gibberish. But let's say you typed in some long thing. 3 times 6 plus 7 times 9 divided by 6. And you press enter. You're like, okay, great. That's nice. If I did second entry, look what it types out for you again. It gives you the last entry. That's really helpful. Let's say you type something really long, but you made one mistake and you realized it. What can you do? Second entry, and then I go, oh, that wasn't a 5. It's meant to be a 5, not a 6. And then I can hit enter. And look how there's only 2 things on there. If I do second entry, watch what it changes to, everybody. What does it change to? You see all those things I typed before that aren't on the screen anymore? I don't know how deep it goes, but it's like you can cycle through a lot of them. It's a really helpful thing. Okay, someone pick this in a problem. What are you gonna have to use? You're really gonna have to use a calculator, but you need to make sure you read the question correctly. We did one like this, didn't we? If x equals 0 corresponds to 2000, x equals 1 corresponds to 2001. So if you want to find out this value when you're at year 2000, what do you plug in for x? 0. If you do 2003, what is x? X equals 3. And if you want, that's not 2003. 2003, and if you wanted 2006, what do you plug in? X equals 6. So what do you need to use to find these values out? Use your calculator and use the y equals thing. So you have to plug that function into your calculator. So everybody do that right now. Everybody sees this function right here? That's the function right here. Plug that into y1 on your calculator right now. Select y1 again, and then we plug in, what was it, 3? enter, and I'm going to do second entry, and instead of 3, what am I going to put in? 6. Your goal is to see if you can see if you agree with these numbers.
Just press bars again.
Each time, yes. There you go.
And you hit function and you enter, right?
Mm-hmm.
That's a whole lot easier.
Is that a whole lot easier than typing it in every time?
Yeah, it took me a while.
Yeah, so look at this one. Yeah, you said you had to do it over and over again, right? So how's this look? This is what you do right there. Ask me, what does this mean? That means adding the two functions together. That is just shorthand for adding the two functions together. What is it not?
Multiply.
It is not multiplication at all. You are just adding the functions together. So if you added these two together, you have x squared and negative 3x squared. How many x squareds is that? Negative 2x squared. If you have negative 3x and negative 7x, how many is that? 10x, and you have 7 and 7, what is that? 14. No, you're adding them. You are adding them. You are adding them. So what about something like this? What's the only difference here? Is this multiplication? No. You are adding together the functions and then plugging in what? 2. So you can add together the functions. You just have, so f plus g of x, what is that? 10x squared.
Minus.
It cancels. That cancels, yes. Now what do we plug in for x? 2. So f plus g of 2 is 10 times 2 what? So that's going to be 40. If you wanted to, because you're adding, you could plug in the 2 first. If you wanted to. Plug in 2 right here. You get 40 minus 4. And what do you get when you plug in 2 right there? When you add these together, what do you get? Same thing. You could plug in 2. For addition, yes. For addition, yes. What about this one? Is that multiplication? No, it is not multiplication. So this is subtraction. There's no multiplication here. You're going to see parentheses next to each other, so sometimes you're going to be cruising along and do multiplication. Try not to. This means, what is that symbol? Subtraction. It means subtraction. It means subtraction. So if we subtracted these two functions right here, what's 10x squared minus 2x minus g of x? What's that going to be? If you subtract these two things, what do you get? 10x squared minus what? Minus 4x. Exactly, because it's negative 2x minus 2x. So then could you plug in 1 if you wanted to? So f minus g of 1, what's that going to be? 10 times 1 squared minus 4 times 1, what's that? What's that? 6. 6. 1 squared is 1. 10 minus 4 is 6.
Where are you? What is this? Yeah, that's on it.
Look, it's the same functions.
That's all it
It's
is.
the same functions. I use this function right here and put it right there. I said negative 2x minus 2x is, and what am I plugging in? 1. What's 10 times 1 squared? 10. What's 4 times 1?
Oh, okay, so whatever like is between g and x that you use to multiply or add or subtract the equations.
Correct. Correct. Okay. Additions are really good at some things and really poor about others. There's a lot of labeling that gets redundant. For example, usually multiplication is this or this, correct?
Yeah.
Here's the thing. If you take more math, closed dot turns out to mean like 6 different things. It's all about context. But when you think about it in the grand scheme of language, right, and right, they're all different things depending on context. It's all about context. This is what this means. The way you say it, g of f of x. G of f of x. Where are you putting f of x?
Into G.
Into g. You are plugging f into g. So what would this mean? H-O-G of x. What does that mean? H of g of x. You're plugging what into what in that case? G into h. So let's just do an example. Let's say h of x was 2x, and let's say g of x was, I don't know, 1 minus x. What do you do with g? What do you do with g? You plug it into h. So therefore, h of g of x, in this case, what's it going to be? 2 times 1 minus x. Instead of x, what did we plug in? The g. All you have to do is read it properly, and these things are super straightforward. Yes, David?
What happens to the x?
By the function. So the intermediary step here is this. It is 2 times g of x. So instead of x, what did we write? Instead of x, what did we write? G of x. But what is g of x?
Oh, because
It is 2 times 1 minus it. So instead of it, what do we now have? Could you then simplify it a little bit? Sure, but stop there for now. Just stop there. So for this one right here, what does this not mean? Do not multiply by 4, do not multiply by 4, do not multiply by 4. This means f of g of 4. This means f of g of 4. So what are we plugging in to f? No, g of 4. We
So
are.
that means you put
Where do we plug the 4 in first?
the x of in the g.
Into g. We plug 4 into g. So what is g of 4?
4 plus
Which is 7. And now where do we plug that 7 in?
into the x.
Ah, exactly. So this 7 goes where? So we know that this is equal to f of 7. Where do we plug that 7 in? Right. So that's going to be 7 squared, which is what? 49. Well, let's change. I'm going to change it just a little bit.
I'm already lost, so this is not.
Okay, so again, first thing you know that means. Plug what into what? You're plugging f of x into g. So that's the same thing. It's just notation. There's no other way around it. You just have to accept it. So if I asked you what is g of f of 4, for example, that means g of f of 4. Where do I plug 4 in first? Into f. Look up there. F of x is x squared. So what is f of 4, Sarah?
16.
Yeah, so it's g of 16. Now let's go to g. What is g of 16?
X plus 30, which would be 16.
Which is 19. Done. You just did g of f of 4. So first lesson here is f of g of 4 was what? 49. G of f of 4 was 19. So does the order matter?
Yes.
Yes. We had f first here, we had g first here. Did it totally change it? It really should make sense because in one case we're plugging g into f, in the other case we're plugging f into g. Yes.
So you have like the
So try that for me. Do f of g of 2 on this one. Do that one for. Do those two right there. What does this mean? Someone who's working on, what does that mean? Sarah.
F of g.
So where do we plug in 2 first? G. What is g of 2? 2 squared plus 5 is what, Noah? 9. So this is f of 9. What is f of 9?
35.
Yeah, 4 times 9 minus 1 is 35. Done.
Oh, great.
Good. Yay. Woo!
Is there a certain way to write these?
Like that. Oh my gosh.
wait,
Now in this one though, can someone tell me what's the difference on this one? Nope. Doing this one first, Gabby. Hold on. You're going to have an equation. What's going to be in it? In x. So what does this mean? F of
G of x.
g of x. And what is g of x?
X cubed.
No. X squared plus 5. Because it tells me that.
Oh, yeah.
So then I put x squared plus 5 into what function?
That's what the
So what is f of x? It's going to be f of
x squared
plus 5 minus
1.
1. Look at this right here, everybody. Do you see 4x squared minus 1? Instead of x, what are we plugging in for x? X squared plus 5. Instead of x, what are we plugging in? X squared plus 5.
you
Instead of x, we are
go
plugging
back
in g of
one
x.
step before what you just did.
Okay,
Where did you?
g of x. Now you can talk.
X squared plus 5.
Wait, what?
Minus 1.
Where? Okay.
This means you're plugging g of x into f, right? That's what I'm telling you it is. What is f of x? 4x minus 1. So instead of x, we're plugging in, say it out loud, g of x. Instead of x, we're plugging in. But what is g of x? What is
So
g
you
of
plug
x?
in that for the x of the.
Correct.
Oh.
Yes. Yes, Hannah.
Do you distribute that?
At that point, you could clean this up and you could call it 4x squared plus 20 minus 1. You could call it 4x squared plus 19. Yes.
And that's the final.
Correct. Now here's the thing. What did we do in the first one? We did f of g of 2, right? What's 2 squared? What's 4 times 4? What's 16 plus 19?
Bingo.
Did it match?
Is this supposed? I thought you said that they weren't supposed to.
When you plug in 2, they will!
Why are we plugging in 2?
Correct. G of f of 2. So what does that mean you have to figure out right now, Noah? Yeah, so f of 2, so that's going to be 4 times 2 minus 1 is what? 7. So not 7, it's now g of what? G of 7, right? We got 7 right here, and we plugged it in right there. It turned into 7. It turned into 7. Now we plug 7 into...
G of x.
You plug 7 into g of x, exactly. So you need to do g of 7. What is g of 7 going to be?
49 plus 5.
Which is?
54.
So this is 54. You plug 2 into f, and then what you get out, you plug into g. So we plug 2 into f, and we got 7. So we plug 7 into g, and what did we get? 54 plus 5. You get 54 at the end. Yes. Let's say I asked you instead for g of f of what? X. What does that mean? Gabby? Yes, so we're plugging f of x into g. So g is x squared plus 5, but instead of x, what are we writing? Yeah, we're writing f of x, right? But what is f of x? So it's 4x minus 1 squared plus 5. And yes, you could simplify this, but this would be very good to get to here. I need you to understand the concept right now, which is this means plug f of x into g. This means plug f of x into g. So we plugged in 2 right here. What's 4 times 2?
8.
What's 8 minus 1? What's 7 squared? 49 plus 5? Does it match? Should it match?
I know this is vector with my phone.
Yes.
Is that 4 squared x squared or 4x squared?
What?
In the bottom one where it's like 4x minus.
How would you simplify that?
Yeah.
It's 4x minus 1 times 4x minus 1 plus 5. You must multiply it out. This. What do you multiply, Gabby?
The numbers, the bases, the bases. Yes.
3 and 5. So you know that part of this is going to be 15. But the rest, what do you then have to multiply? Yes. You add the what? The exponent. So the x to the 7th. Correct. Very good. Very good. Very nice. So these are pretty easy as long as you take them carefully. No, this is the next section, but many of you have seen this before, so I wanted to end with something that's nice. What's negative 4 times 3? 12. And what's 8 to the 3rd times 8 to the 5th? Oh, look. That's kind of nice, isn't it? Yay. What about when you have a minus sign? What do those arrows tell you need to do? One word.
Distribute.
Mm-hmm. So what? Can someone tell me what this answer is? Hannah.
It'd be negative 16x to the 3rd
Mm-hmm.
minus.
Nope.
Plus, just kidding.
Yep.
18x to the 7th.
Correct. Raise your hand if you're okay with what we just did.
Wait, so you distribute the negative.
The whole thing. Correct.
So
Correct.
So you don't
Yes.
solve it.
There's nothing to solve because there's no equal sign.
The bases are.
You mean like.
There is no equal sign. There's nothing else to do on that. You are done. There is no equal sign
Why
on that.
can't you do?
What?
Why can't you add?
Because you're not multiplying.
Because it's a plus sign. There's nothing to do on that one. You are done. There is no multiplication.
Is that what's multiplication? You do negative 16 times 18.
Correct. Someone new. Meg, can you tell me what the answer to this one is? Excellent. You just distribute again. Can you combine anything there? Can you combine any of the terms? You absolutely cannot because there's no multiplication anymore.
Or division, right?
Yeah. See that?
Subtract.
What are the operations involved right there? Adding and
Subtract.
subtracting. Can you do anything with the exponent rules? No, you can't. So this is where I need you to not use a certain word because it's a really bad word to use in my... No, we will distribute. That's fine. Sometimes this... Okay, I won't say it's bad, but here's the thing. It's a really limiting word because it's really limiting. I want you to remember something else.
I don't even know.
Good. Everything times everything. So what does that mean you do here? Everything here gets multiplied by everything here. It's nice if you did a common order. So you just need to keep track. What is 3x times 2x squared? 6x to the third. What is 3x times x? Squared. Nice. And what's negative 4 times 2x squared? Shh. Answer the questions first, and then you will get to your questions. What is negative 4 times 2x squared? Negative 8x squared. And then what's negative 4 times 4? Exactly. We will clean up in a second, but my point is everything in the first one gets multiplied by everything in the second. Are there any other pairings that we could do? No. The reason this is important is, can you have more than 2 terms inside of parentheses? Could you have 3 terms and 3 terms? Sure. Could you have 3 terms and 2 terms? So FOIL doesn't work for those things. You just need to multiply everything in the first times everything in the second. Now, at this point, can you simplify a little bit? Yes. You have 6x cubed. Then what? Minus 5x squared minus 4x. This you would be done. The key thing I really want you to remember, and I think this is super important, is everything times everything. Because you could have more than 2 terms. You could have more than 2 terms. I'm going to give you something you never need to pay attention to. In your book, they give you this multiplying polynomials vertically. Skip this, ignore this, never do this. I find this to be massively confusing and useless. Don't do it. Don't. Do you see the nice little arrows I draw right here? That is way easier to keep track of in my opinion. This right here muddles it, it makes it worse, so we're just skipping it. Simplify this one for me right now. Marion, what do you got?
6.
I don't like highlighter, sorry. Yep, 6x what?
Squared.
Yep.
Minus.
Mm-hmm.
Minus 8x.
Okay. Minus. Nope.
Oh, no, because it's the
Minus.
more.
Who agrees with that right there? Can it be simplified a little bit?
Yeah.
Yes, but who agrees with that? So
Sorry, I like to do it this way.
it's totally fine. So who agrees with that as a final answer? Yay! If you keep track of all the pieces, it's really, you absolutely can do this. What's the phrase? First question, how many products are you going to have to do? Nope. Nope. 6 of them. Because there's 3 in the first and 2. So how many pairs do you have? 6. So do the multiplication and simplify this. And then at the end, wait patiently until I ask you for your... Multiply these 2 first like some of you are doing. What's x times x? What's x times y? And what's x times y? And what's y times y? So can you simplify this?
Yes.
What does it turn into?
X cubed
Plus.
XY squared.
Nope. What's one apple? 2xy plus y squared. But what is still on the outside, everybody?
One more.
X plus y. So what do you have to do one more time?
X plus y.
Yay!